on this 2010 to 2017 Honda Accord with the 2.4 gas engine. P0328 points to a knock sensor circuit high voltage condition. In plain terms, the PCM may be seeing the knock sensor signal circuit higher than expected. The driver may only notice the warning light, or the engine may feel like timing control is being affected. Possible fault areas can include the knock sensor, its connector, the knock signal wire, the KS GND wire, connector issues at the PCM, or a PCM software or PCM-related issue. Before testing, record the freeze data and any onboard snapshot. Then start with the basic system checks and follow a structured diagnostic approach. Start by verifying the problem. Turn the ignition on, clear the code with the HDS, turn the ignition OFF, then turn it back on. Now check pending and confirmed codes with the HDS. If P0328 comes right back, the failure is duplicated and you can move into circuit testing. If it does not come back, treat it as an intermittent at this time. In that case, check closely for poor connections or loose terminals at the knock sensor and at the PCM before going any farther. With the ignition OFF, disconnect the knock sensor 2P connector. Turn the ignition back on and measure between knock sensor connector No. 1. The WHT knock wire and connector No. 2. The BLK KS GND wire. You are looking for about 5.0 V. If that voltage is present, the diagnostic path calls for replacing the knock sensor, then moving to repair verification. If that voltage is not present, continue with the knock line checks. Leave the knock sensor connector disconnected and keep the ignition on. Measure from knock sensor connector No. 1. The WHT knock wire to body ground. Again, the expected reading is about 5.0 V. If you have that voltage, the knock wire is considered okay and the next check is the KS GND line. If you do not have that voltage, turn the ignition OFF, jump the SCS line with the HDS, and disconnect PCM connector C, the 51P connector. Then check continuity between knock sensor connector No. 1. WHT and PCM connector C No. 29 WHT. If continuity is present, the knock wire is okay, and the path moves to updating the PCM if it does not have the latest software or substituting a known good PCM. If continuity is not present, repair the open in the knock wire between PCM C29 and the knock sensor. Then verify the repair. Next, check the ground side of the knock sensor circuit. With the ignition OFF, the SCS line jump with the HDS, the knock sensor 2P connector disconnected, and PCM connector C disconnected. Check continuity between knock sensor connector No. 2. The BLK wire and PCM connector C No. 28, also BLK. If continuity is present, the KS GND wire is okay, and the path again moves to updating the PCM if it does not have the latest software or substituting a known good PCM. If continuity is not present, repair the open in the KS GND wire between PCM C28 and the knock sensor. Then verify the repair. Keep verification separate from the testing. Turn the ignition OFF. Reconnect all connectors. Exit SCS mode with the HDS. Turn the ignition on. Reset the PCM with the HDS. And do the PCM idle learn procedure. Then check pending and confirmed codes again with the HDS. If P0328 is still indicated, go back to connector quality. Check for poor connections or loose terminals at the knock sensor and the PCM. If a PCM was substituted and the code no longer returns, replace the original PCM. If P0328 is gone, troubleshooting is complete. If other codes are present, check what they mean first. The key on P0328 is to prove whether the circuit can carry the expected signal and ground path before blaming the controller. Verify the code, check the sensor circuit, isolate the knock and KS GND wires, then finish with a clean repair verification. For more diagnostic training, visit Diagnostics.com.